Hello there, once again. Welcome back. I just realized that I haven't been uploading this source code, so I'm just doing that now. So for those of you who want to try and build some of these things and would like to source, it should be there right about now. The reason the reason I give these a 7Z extension, even though they're zip files, is because zip files, unfortunately, appear like extra folders, and I don't want that, so I just rename them to .7Z, so I can still look at them this way, but I don't get that extra folder. Anyway, back to our story. I don't know if you recall, but I was saying that at one point I was looking at that heap report, and I couldn't find the stack. Now what am I doing here for? That's good enough. Here's the heap report. See? Now, the question is, actually, this is a good spot to be in. Address of each instance. Now that looks like to me a stack address. That's what we're used to. 1, 2, something, something. Similarly in here. Now, if you keep looking at this output window, now when I add this console, I think something's going to happen. Nope, nothing yet. Nothing happened. Definitely when the dialogue gets going, something's going to happen. There, see? A whole bunch of things got loaded into, well, some of it was there before, but some of these extra things got listed. Now I don't know, maybe I'm just obsessive, but what I did was, these things that dump into the little box here, after I create the console, in addition to dumping here, they dump here. So it gives me a look. Okay. Now these numbers look like they make sense. But you're going to find, okay, here's all the modules. First, we went from 5 heaps up to 9. And I don't see anything with a 1, 2, 0, 0, 1, 2, anything in here. That is, wherever the stack is, it's not being, this just means it's not being created through the heap malloc, which is fine. Okay, it's being created somewhere else. But I don't know how to find out how or where it's created. And it's been bothering me. Still okay? Yeah. Now here's something that one can do. And this is kind of interesting. Well, first, this is going to crash. Here I am deciding that I would like a 3 megabyte character buffer. Okay. I'm going to try to run up to this point. And it crashed. Now what's interesting is this code. This code is not something I've seen before with the console programs. When I got like a stack overrun, stack overflow it says, And you see what it's doing here is it dynamically grows the stack. You see, there's a lot of explanation here. Okay, unable to grow stack exception. So there's some kind of growing of the stack, and they use something called a guard page. They have I guess, a page just refers to a block of memory, usually always 4 kilobytes. That's the definition of a page, at least for an x86 computer. And there are two kinds of exceptions. One is an okay one. So you never trap this. It's used by the OS to grow the stack on demand. And then there's this other exception, which is bad, that we can't grow the stack anymore. So I don't know how it decides that it's unable to grow the stack any further. But okay, no problem. What I'll do is simply change my stack size. So I want a 3 megabyte array. I'll make a 5 meg stack. Now I should be able to run up to here. Okay, no problem. Print it out. Now, see, these numbers have changed. It used to be 1, 2 something, and now it's 9, 5 something. Now what's interesting, maybe interesting, I don't know, is to print out, again, this thing, and see if there's anything in here, in that range. Now, I'm also printing, or I was printing, I'm printing out a similar thing here for just a local variable, and one of these things passed in at the bottom. Where's the bottom? Now this is 6.5. Oh no, that makes sense. That makes sense. The other one was 9.5 and 6.5. You see, at the 0th entry is going to be the lowest. Is going to be the biggest number. Alright? Now it should be this small one. Well, what's that difference anyway? In decimal, this number, I have a feeling it's going to be 3 megs. About. Whoops. See? 3 megs. Now, let's see, how does this make sense? The 0th element of this array should be, if it's increased. Oh, I don't have this. Okay, that makes sense then. Okay, this is not. It says the 0th here, but I'm not. If I printed out the 0th, the actual thing that I'm saying I'm printing out, it should come out to the same as that other thing. See, 666, and h instance, the next variable, a variable passed in. is 3 megabytes away from the 0th entry of this array. My tiny little 3 meg array. When I print this out, I get numbers near the beginning, or well, the normal numbers. So it seems like, okay, the stack grows dynamically. It doesn't use heat balance. Okay, I can't look at it somehow for some reason, but everything seems to make sense. But watch this. Suppose I interchange these two lines. Just to keep nothing, no real change in my program. Just I decide I'm going to allocate my $1 trillion array up here instead of down here. Should be fine. I have a 5 meg stack. See, it looks like everything's fine. There's that same difference. I can do it over and over again. But now when I quit, I get this stack overflow. See what I'm saying? And that's the bit that doesn't make any sense to me. If I do it here, it's okay. But if I do it here, when it's coming out through user 32 and NTDLL and all that, it sees not when I do this part. It's fine with that. But when I just do the end dialog bit, it says I've overrun the stack. And I think that's a bug in this code, as a matter of fact, because there's obviously enough stack, and I was using it, and that's not that's not an empty declaration. I'm filling this up with numbers. If it was a real stack overrun, things should have crashed long ago. Anyway, sorry for that diversion. If anybody has an idea, let's see what's going on. Oh yeah, a curiosity. Here's the thing. I don't know if you know anything about code pages. Do you know what a code page is? See now, this is one of the things that I had to learn about when I was writing computer games, and the games had to be marketed and sold in various countries, especially in Europe. And the Europeans tend to not use Unicode. They just have a different code, what they call a code page. Now this box, these console boxes, so I didn't even do anything. I'm gonna get rid of this. Turn it back. Interchange them back. Well, that experiment's dead anyway. These console boxes like this have something called a code page, and you can see what that value is by typing the command mode. Now, what a code page is in a sense, it's like a palette, okay, which you might not know either. It's a mapping, okay, of numbers from 0 up to 255 to a character code, or well, here, it's easy enough to look at. This is a bit of a diversion, but it's kind of on 1. Now, these, well, null is never anything. Usually the first 30 will change from one code page to the next, and what you're seeing here tells you which character is associated with which code, okay, code page number. Now, let's see. I'm just looking at this. 1D and 29. That is 29, okay. I want to find something that's weird. Okay, now this is a great big number, right? So this is the number that's listed here is the Unicode, what they call the Unicode number in hex associated with the character code for this particular code page and that particular code. You can, if I wanted to generate one of these characters in code page 437, all I need to do is enter in a character 219. Character 219 will go to the table and look up the value that's supposed to be associated with that number. It turns out its Unicode value is 2588. Now, that was 219, right? I hold the Alt key down and type the numbers 219. I've already done that. When I release the Alt key, which I'm about to do, there it is. See? So I entered a character 219. And I can do that for this one, 195. That gives me that, you see. And that's because I'm using this thing is representing its characters as though it were code page 437. Alright, now there's another code page, which is a standard code page, and that's the one that would be used by, let's say, Notepad. Is this an empty Notepad? Yeah, okay. I'm going to do the same thing in two different places. Well, let's see, one of the ones, visible ones. This, what did I just do? 179? Well, how about 180? Alt 180 release. Okay, now go to Notepad. Alt 180 release. You see, I got the same thing, but this is not using any code page or anything at all. You see, it's interpreting the entering of Alt 180, right, as this Unicode character. So that's why it gets confusing. You see, the character 180, using what they call the Western European Windows code page, should be this character. And I can enter that character in too. In fact, you can enter all of these ones in exactly the same manner as these ones, except you need to add a 0 in front. So for instance, Alt 180 release gives me that character. You see? This is 180 for code page 1252. And 180 code page 437. Right? So now we've got a mixture, and if I try to save this as an ASCII file, it's gonna tell me I can't. Okay, or ANSI, I guess. It's gonna get mad. It should. Come on. Oh, I'm gonna give a name. Can't save. The unsavable. See? This file contains characters in Unicode format, blah 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 blah. But if I get rid of this one, and only this one, it'll let me do it. Unsavable. No problem. Put this back and I can't save it. See? Because this thing is implicit in all of these Windows things, is that it's that the code page is this 1252. It's the standard Windows code page. Okay, this is the old DOS code page, and these characters are therefore considered to be not within the happy ANSI code page. Alright. So, I know this is a big diversion, but anyway. Well, here I am trying to make this thing happen. Dump process heaps, right? Now if I take away the code I added, you'll see what I get. Where is it? It's got to be in here. How can I make it not work? I can get rid of this. Alright. Now if this should become gray, and this should become, it'll go back to what it was originally. Alright, anyway. Just to show you what you get. See? It's got all these horrible characters in it. All these, I think it's a pie or something. Okay, and that's because of this character. Now this character, it's so painful. I got that character from here, 183, I think. That looks like it. Alright? And that's a B7. Well, it turns out that that character exists on both of these code pages. So I thought, okay, well that's great. I'll just put it in as 250, right? In my thing here, and I happily type, Alt 250, and it gives me the same character, right? But it's not. That's the lie. You see, what it's done is it's taken that thing that it knows it got from code page 437, and it found a way to remap that character to code page to this code page 1252, and I get the same pies everywhere. So what's the answer? Unicode. So I invented another new macro that converts from multibyte, this multibyte report, right, into Unicode. So this WC report is the Unicode version of this and then I use the wide-car version of the report thing, which is hooked into the printout, and so it's printing it out as Unicode, and that's why now it looks correct, like that. Very silly thing to worry about, but I've probably used up the whole thing. I've used up all my time just on that. Well, maybe I can just leave this as an aside or something. What I want to get to, if I can stop obsessing about that stack, which I've given up on, I'm pretty sure, is now what we want to do. You have a pretty good idea of what's going on here. If you recall from this loop, this here get window text. Let me use that function. Now what I want to do is get the handle to the window with that particular ID. Now that's possible, and I'll just show you how to do it. Get item. Yeah, there we go. Parent dialog, and then the item, which was 1001. I know I should use the number defined here. Okay, what was it called? Edit one. So it's assuming that that is not null. I can use this get window text, and I'll fix this up eventually so that it figures out the length and everything. Better not make it 3 megs. We'll try 512. Set that to 0. Now that will get that into a buffer, right? Now what I want to do is I want to keep that. So let's make a global just for now. And I'll just assign that. Like that. And then at the end of our lost. No, and something like that. Now I'd like to just print out that string. If I get an ID, okay. This is the typical sort of thing that happens. I'm using a global, and that's obviously not preferred. But now I'm going to just type something in here. Here is some text, and enter, and a few, and more, and hey, why don't I put, no, never mind. I was going to put in one of those funny characters. Alright, now I'm going to click OK, and there, you see? The get window text function, which takes a handle, and you can put any handle, as you've seen already in here, extracts the caption text from any window. So that's how we can get the text out from one of these controls, and it would be probably some use to allow more than 4 lines of text in that little text area. So I'll do that too. And now, once that's done, what we want to do is try and find a way to turn this whole thing into an object that it somehow knows where to put this text. This is just some global function, right? And there's a way to do that, and I'm going to show you that next time. Okay, sorry if this was a waste of your time, but anyway, see you next time.